Welcome to Understand the Math. In this problem, we're asked to find the standard matrix T from R2 to R2 that first reflects points through the vertical x-axis and then reflects points about the line y is equal to x. To begin this problem, we want to remind ourselves that the standard matrix of T is our matrix A, and it's equal to the transformation of E1 and the transformation of E2. Our E1 is 1, 0, and our E2 is 0, 1. So what we're going to do to solve this problem is we're going to start with E1 and E2, and then we're just going to see how they transform. And we're going to look at one transformation at a time. So I think it might be helpful to call this one our T1, the one that reflects points about the vertical x-axis. And then let's call this one our T2, the one that reflects points about the line y is equal to x. I went ahead and gave us a graph to start. And what we're going to do is we're going to begin with E1 and E2. So I'm going to go ahead and plot those. E1 is 1, 0. So I'm going to put that right here. And we're going to call this E1. And then E2 is 0, 1. And we're going to put that right here. Now let's look at our first transformation. We'll go back up. Our first transformation reflects points through the vertical x-axis. So we're going to be reflecting about this axis. So E1 is going to stay the same because it's already on the x-axis. So let's label this, and we'll pick a different color here. Let's label this one as T of E1. And now let's find T of E2. Oh, and let's label this as T1 of E1 because we have two transformations. So E2 is going to come down here because it's going to reflect around the x1 axis. So let's label this one as T1 of E2. Now let's look at the second transformation. The second one is we're going to reflect points about the line y is equal to x. So let's look at T1 of E1 first. If we reflect that about the line y is equal to x, it's going to come up here where E2 was. So let's label this one as T2 of E1. Now let's look at what happens to T1 of E2. When we reflect that one about the line y is equal to x, it comes over here. So we're going to label this one as T2 of E2. Our standard matrix A is our T of E1, T of E2. And remember, these are the columns of A. So we can write our standard matrix A as our first column, which is our T2 of E1. Let me go ahead and highlight that. That's this one. And that's going to be the vector 0, 1. And then we have our second one, T2 of E2. And that's going to be the vector -1, 0. So there's our standard matrix for this transformation. I want to do one more thing before we finish this problem. This problem can also be solved using matrix multiplication, and I want to go ahead and do that for you. We can say that our standard matrix A is A2 times A1, and A1 comes from the standard matrix for our first transformation, and then A2 is the standard matrix for our second transformation. Our second transformation is when we reflect vectors about the line y is equal to x. So the x and y components change. So our A2 is 0, 1, 1, 0. And then our A1 is when we reflect points about the vertical x-axis. And for that one, our x stays the same, and then our y changes, so it's 0, -1. And if you go ahead and you multiply these out, you can see that we're going to get the same thing that we did from our graphical method, 0, 1, minus 1, 0. So whenever you're doing linear transformations like this and finding the standard matrix, or if you remember what the standard matrices are for each of these transformations, you can do it algebraically.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.